All right, this problem is to help you with number 7 on this week's CR. It says Mrs. Redford created a table to show a number pattern. She applied the same rule to each input to produce each output. So when she put a 2 in, she got a 5. 4, she got a 9. 5, she got an 11. 6, she got a 13. You got to figure out what's the output for 7, for 9, for 10 to 12. Okay. Complete the number pattern table. Oh, okay, great. Explain the rule she used to create the pattern. All right, so we have to figure out what's happening going across the table. Lots of patterns we can find. We could embrace some patterns going down the table. I'm going to take the most direct route and go across the table, but there's lots of patterns that can be found. So here's what I would do if I was trying to figure out how to get from 2 to 5. I'd say, what could I do with 2 to get really close to 5? What could I do to 4 to get really close to 9? Is there something I can do to 4 to get me really close to 9? All right. I'm just trying to process through this. What can I do to 5 to get me really close to 11? Something I can do to 5 to get me close to 11. What could I do to 6 to get me really close to 13? Different things you can think of. But I might say, well, 2 times 2 gets me to 4. It's pretty close to 5. 5 is just 1 more than that. 4 to 9. 4 times 2 is 8. 9 is just 1 more than that. 5 to 11. Well, 5 times 2 is 10. Well, 11 is just 1 more than 10. From 6 to 13. 6 times 2 is 12, and 13 is just 1 more than 12. So that's kind of how I build the rule. I try to figure out something I can do with the first number. A lot of times it involves multiplication and then an addition or subtraction. So what can I do to that first number? Is there something I can multiply that first number by to get me really close to the second number? And then I figure whether to add or subtract on. It's just a strategy I use, and if that strategy doesn't work, I try something else. But here, now that I'm pretty convinced this is what's happening, to get from 7 across the table, I would have to do 7 times 2, figure out what that is, and then my final answer will be just 1 more than that. Well, 7 times 2 gets me to 14. 1 more than that is 15. All right. 9 times 2, see what that is, and then my final answer will just be 1 more than that. 9 times 2 is 18, and 1 more is 19. I'll go to 10. 10 times 2 is 20, and 1 more is 21. Then I'll go to 12. 12 times 2 is 24, and 1 more is 25. There's lots of things that we could do. We could have also embraced patterns going down the table, but that won't really explain the rule. And I knew eventually we'd want to explain the rule, and this is the rule that you would follow when they say explain the rule. So for our rule, a couple ways we could explain it. You could do 2 times the input plus 1 equals the output. And that would be explaining the rule. New York State would accept that on a state test. You could say multiply, and then you could use words if you want. Multiply the input by 2. Then add 1 to get the output. Lots of ways. You could describe it as I double the input and then add 1. Lots of ways to describe it. But there you go. That's the rest of the table, and that's the rule. I actually think your table might even be a little less involved in this. It might be just a single step. See how ours was 2 steps? You had to multiply and then add a little extra on. Yours might just be a 1 step. Hopefully that helps.